Today we will talk about simplifying fractions and mixed numbers. Let's assume I have a case where I divide my whole into 4 pieces and I took 2 pieces out of it. If you look at this, I know that this is 2/4. However, I can squint my eyes and kind of ignore this little line in here. And let's look at it now. And squint your eyes. Now this looks like I have 2 big pieces and I took 1 out of it. So in terms of the blue area and the red area, they are the same area. So that means these 2 fractions have to be equal. So what I did was I simplified a fraction. I made the numbers smaller. So let's look at it. 2/4. What you're allowed to do is divide the top by 2 and divide the bottom by 2. And I'll give you 1/2, which is the representation of the simplified form. So I am allowed to divide the numerator and the denominator by a number to make the numbers smaller. Let's look at another example. Let's say I have 8/12. I have a whole. I divide it into 12 pieces. And then I took 8 pieces out of it. Here's 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 12. Now I'm going to go and I'm going to kind of look at this a little differently with the red. The same shaded area. And let's ignore this. Look what you have. Now you actually divided this into 3 pieces. Look at it. Here's 1. Here's 2. And here's 3. And took 2 out of it. So the red one indicates that this is actually the same as 2/3. Let's see if I can get to 2/3 from 8/12. And as you know, I'm allowed to divide the top and bottom numbers with the same number, a common factor, to make them smaller. Let's divide 8 by 4. Let's divide 12 by 4. You actually got 2. 12 divided by 4, 3. 2/3. So 2/3 is the simplified version of 8/12. Let's do 4/20th example. I have 2 rows. Each row has 10. So I'll take 4 out of it. 1, 2, 3, 4. Okay, so I used to have 4/20th. And let's see how I can look at this. Instead of looking at this, okay, let's do it in blue so that we don't get confused. So I took 4 pieces. 1, 2, 3, 4. Now I'm going to look at this problem differently. Instead of looking at these numbers, I can look at it as I have 1 piece here, another one here, another one here, another one here, and another one here. So I'm ignoring these divisions. And I took how many out of it? I took 1 out of it. So the simplified version is I took 1 out of 5. So could I have gotten to that from the blue one? Yes. Divide top and bottom by 4. You'll get 1/5. So 1/5 is the simplified version of 4/20th. Now, I can do the same thing with the mixed numbers. Let's look at it. Let's say I have 3 2/4. What I can do, I can divide top and bottom by one number, which is 2, and I will get 3 and 1/2. 3 and 1/2. So the red is the simplified version of a mixed number. Let's do another one. Let's say I had 2 and 8/12. What can I divide top and bottom by? By 4. 8 divided by 4, that's 2. 12 divided by 4, that's 3. So this is the same as 2 and 2/3. 2 and 2/3. Let's do another one. 4 and 4/20. Divide the top and bottom by 4. You will get 4 and 1/5. 4 and 1/5. So I can do the same thing by just tackling the fraction portion of my mixed number. But what happens when I have big numbers and I cannot think of what to divide the numerator and the denominator with? Then I will just show you the prime factorization method. Now, let's remember the prime numbers. These are numbers that are only divisible by themselves or 1. The smallest prime is 2. 2 divided by 2 is 1. 2 divided by 1 is 2. The next one is 3. 4 is not prime because 4 is divisible by 4, 1, and 2. So 5 divisible only by 5 and 1. 6 no. 7 yes. 9 no. 10 no. 11 yes. The next one is going to be 13, 14 no, 15 no, 16 no, 17. So these numbers are only divisible by themselves or 1. Okay? And so forth. Now if I'm asked to do a problem like this, 36/40, one way is to think about dividing them by a number. Let's divide them by 2. I have 18/20. Here we go. I'm done. Actually, you're not. You could have divided this by 2 one more time. Oops. One more time to get to 9/10. And that would have been the final version of it. But the problem is, if I do it this way, I probably am going to miss it. So what am I to do? So let's use the prime factorization method. So if I use that method, I will get 36 and I will start to prime factor it along with 40. Prime factor it. Now I think of the smallest prime that divides 36. Since that's an even number, it's 2. 18, even number, again divisible by 2. 9 is divisible by 3. So 36 is simply 2 times 2 times 3 times 3. So instead of writing 36 over 40, I'm going to write 2 times 2 times 3 times 3, which is 2 times 2 times 3 times 3. Now let's do the same thing for 40. I'm going to divide it by 2. This divide by 2. This divide by 2. Then I'm going to have 2 by 2 by 2 by 5. 2 by 2 by 2 by 5. If I do it with the prime factorization method, look what happens. When I will double them up and cross them out. And you'll actually get 3 times 3, 9. 2 times 5, 10. There's no way that you can miss it. So there is a danger by just thinking of a number that divides both, but there's no danger with the prime factorization. So let's do another one. Let's say I am trying to simplify 66/80 with the prime factorization method. What I'm going to do is I'm going to go to the side and make my trees to prime factor. Smallest prime that divides 66 is 2. 2 times 33 is 66. Smallest prime that divides 33 is 3. 3 times 11 is 66. So 66 actually is 2 times 3 times 11. Let's do the same thing with 80. Smallest prime that divides 80 is 2. The smallest prime that divides 40 is 2. Smallest prime that divides 20 is 2. Smallest prime that divides 10 is 2. So I have 2 times 2 times 2 times 2 times 5. Now I'm going to go cross out the same numbers, 2 and 2. There's nothing else. Now I have 3 times 11, which is 33. Then I have 2 times 2 times 2, that's 8, times 5, 40th. 33 40th. And there's no way I missed it.